Hello and welcome to part 2 of the Trusser instructional videos. We'll be dealing with the geometry today. We've already set up our parameter list. The parameter list acts kind of as a variable list. That way we can define points and lines using these variables, and then we can go in here and change the variable, and we don't have to worry about every single individual point that was defined using these variables. So to begin, I think it's always best to start with the origin. So 0, 0. If once we hit add, we are given all these options. We can add a point using values, and we want to use the x and y values of 0, 0. Hit accept. I think another good point to add is going to be the span in 0. The span represents the end of the truss. You'll notice that we have 2 points now, and from these 2 points we want to build the rest of the truss's geometry relative to these 2 points. So a good way to do that is to see that there's a point field on the x and y. Once we're in values, there's x and y value, and then there's a point field. Highlighting this point field and clicking a point, the closest point that you click next to will be automatically entered into the point field, and then you'll be asked for an x and y value. Now these x and y values are no longer relative to the origin, they're relative to the point that you picked. So the third point that we want to put down on to define our truss is the point that represents the height of the butt cut above the bottom of the truss. So to do that, we want 0 relative to this point right here, 0x change, and then we want to go up butt BC, which is our butt cut, which is a parameter. You notice here that we have BC relative to 0.0, and we'll hit accept. Now it appears that nothing happened, but if you zoom in, you can notice that this is now kind of a figure 8 shape. It's no longer round compared to this one. Also, you notice that if we highlight point, click here, and put another butt cut point on the right side, we get this shape. So zooming out, we need to add in a point that represents the top of the top chord. The reasons for adding these specific points will become apparent, but it's highly recommended that you use these points. So we're looking for the point that represents the top of the top chord directly above our other sets of 2 points. So to do that, we're going to first select the points that are above our original 2 points. Relative to them, we want 0x change because we want it to be directly above, and we want it to be the length of the wood directly above that point. So if you kind of think about this, if we had the board laying horizontal, then that would it would only be the width of the board. Now if the board was vertical, then the distance would be the length of the board. So kind of using that to organize your thoughts, you might be able to see that the actual height directly above those points of the top chord is related to the angle that the top chord is raised at. Alright, so Trusser has some built-in functions. You can look in the README file provided on the website to find these built-in functions. The one we're going to use here is the rise, because the rise is the technical term used to describe the vertical length directly above a point of the top chord. And rise takes the top chord width and the pitch in that order. Notice that top chord width and pitch are already defined. They're already parameters that we've defined, and we get a point once we hit OK. Now we're going to go ahead and do the same thing on the other side. 0, rise. From these 2 points, we kind of want a line that represents the top of the top chord. That way, well, really we want a point that represents the peak of the truss. The easiest way to do that is to see that we can make a line. Now we want to make an angled line. It's going to ask us the point through which the line will pass and the angle. So we'll pick our top point, and we want it to rise at an angle of the pitch. Now notice that the angle function was just used. The angle function is described in depth in the README file, as are all the built-in functions. But very simply, it just takes the pitch as an argument and returns a degree angle. We want to have another line. We don't want them parallel. We want them to intersect. So we're going to this time do the negative angle of the pitch. And notice that we're beginning to see our triangle shape of our truss. Other important lines are a vertical line on either side of the truss. These lines are used to cut the bottom cord, that is to tell the bottom cord to stop or to be in between these two lines. We want to offset a line, which is what I'm doing right here. If you see the offset button, we'll click, it'll pick the line that we want, and it'll ask the distance that we want it. Now if you'll remember, we have a left overhang, which is a variable that we've picked, and we want that left overhang distance to the left of the line. Notice that we get the line here. For this other line, we want the right overhang. The reason that we use two separate variables and not just one for overhang is because you might have an asymmetrical truss in which the left and right overhangs are different. We want this to the right. We'll hit accept and we'll see this line appear here. Another line that we're going to want is a horizontal one representing the bottom of the bottom cord or the bottom of the truss. This is easily done by selecting point horizontal and then the point through which we want the horizontal line to pass, which is point 0. These lines are kind of hard to see. If you look here, they're not quite as red as the other ones. That's because they're sitting right on top of the green and they kind of meld together and make a sort of yellow color. Another important line that we're going to want is a vertical line, but we want it offset. That way we can have a splice point for the bottom cord. The reason for this is that if you get a truss that's over 20 feet, it's going to be extremely hard to find lumber that's over like 20 feet or greater. So you're going to splice two pieces of wood together. To do this, we're going to pick our vertical line over here, not our overhang line, but the left line. On the axis, and we're going to offset it by distance of splice in the right direction. The final thing that we need to do is to have a point at the peak of our truss. We're going to define a point from the point section with the intersect. That takes the intersection of two lines. You can click your two lines and it'll automatically fill in, hit accept, and you'll see the point appear. The last line that we need before we're done is a vertical line running through that point so that the two top cords can be cut right here. If you're confused by my referencing to cut, that'll become readily apparent in the next video, but basically Trusser needs lines to define when and where a board starts and stops. So with these lines, we should be able to make our truss entirely. That's what we'll be doing in the next video. Thank you.